let's see how to answer this question using the pre-built-in calculator function for the normal distribution. As you read through the problem, the first thing that lets you know you'll need the normal distribution is this little bit about how it's normally distributed. Then we'll need to identify the mean of the distribution and the standard deviation. So for all of this problem, we have a mean mu of 98.20 and a standard deviation sigma of 0.62. Now part A asks us to find the probability that a person has a temperature above 99.5 degrees. Now because it's normally distributed, the picture looks like this, with the mean temperature of 98.2, and we want the probability that someone is above 99.5. So 99.5 is here somewhere. What's the probability that this person has a temperature that value or higher? As soon as you see what is the probability, you recognize that that's the normal CDF. The normal CDF answers that question. What's the probability? So we would like to find it. Normal CDF is the normal cumulative distribution function. It's a distribution, happens in the distribution menu. So we'll turn the calculator on. Choose the second button and then variables key for the distribution menu. And scroll down to number 2, normal CDF. Now we need the lower bound, the lower place, the place that we begin caring about the area is at 99.5. And the place that we end is not really anywhere soon, right? It happens to go out toward infinity, but infinity is not a key we can enter, so let's try 10,000 or 10 million, anything that's sufficiently large enough for us to get that area. The mean of this distribution, as we identified, 98.2, and the standard deviation 0.62. Paste that in there. That's normal CDF, minimum temperature 99.5, maximum temperature 10,000 or more, mean 98.2, standard deviation 0.62. So you press enter, and we get 0.0180. That's the probability of being more, of X more than 99.5. That's the temperature. Right, so what for part B? The hospital wants to select a minimum temperature. So now what is the temperature? So that only 1.5% of people exceed it. Now that question looks like this. Here's a normal distribution. The mean is still 98.2. But there's some temperature here, but we don't know what it is. Some minimum temperature for which 1.5% of the population has that temperature or higher under the assumption that they're healthy. That is an area of 0.015. So we would like to know what value that is, what cuts it off. When we see that question, what should a temperature be? What should some cutoff be? And we're given a percentage. That's the inverse normal. The inverse normal needs the area to the left. So if we have 0.015 area to the right, we need to know this area to the left. That's what the calculator will take. So that's 1 minus 0.015, and our area to the left of 0.985. Then it needs the mean. The mean of the distribution is 98.2, and the standard deviation is 0.62. So in the distribution menu, again, right under normal CDF is the inverse normal. Area is area to the left. You could put the 0.985, or you could even put the 1 minus 0.015. Mean 98.2, standard deviation 0.62. Paste it in there, and an inverse normal gives us a minimum temperature of 99.545456 degrees. So that at 99.5, if people are healthy, only 1.5% of the population has a temperature higher than that. That's the cutoff.